If you watched any of my videos, you know I like Sequelize. So I decided Sequelize deserves a video of its own. We're gonna look at Sequelize in the context of Node.js and Express to learn how to build scalable REST APIs. The project will be fully in TypeScript, so I'm gonna show you how to use Sequelize with a TypeScript. Not that many videos out there do that. What is Sequelize? Sequelize is a powerful ORM or object relational mapper that helps you map your data in a database into your application models. We will learn how to set up those models and how to create migrations, how to validate data with those models, and how to relate that data using one-to-many and many-to-many associations. I will also show you cool features of Sequelize such as accessors, virtual fields, hooks, and soft deletes. Finally, we will learn how to populate your development project with a fake data using Faker.js library and Sequelize seeders. Database-wise, I'm a proponent of using the same database in the development that you use in production, so I'm going to show you how to use Docker and Docker Compose to set up and configure MySQL database. You can use this approach to set up and configure any other database such as PostgreSQL. As usual, the code to this video is in the description below. Let's get started. Sequelize is a powerful ORM object relational mapper for Node.js that makes it easier to work with relational databases like MySQL, PostgreSQL, SQLite, and MS SQL. Instead of writing raw SQL, you define models in JavaScript and use intuitive methods to query and manipulate your data. It supports migrations, validations, associations, and more, making it a great tool for managing your database layer in a structured and scalable way. To save us some time, I scaffolded a Node.js project. It has a basic setup with a TypeScript, ESLint, prettier, and jest. It uses .env CLI to load env variables in development and TSC watch to automatically restart the app on saved changes. To make debugging easier, I enable TypeScript source maps in development. Let's go ahead and install Express library. We will install Express, Morgan, and Chorus npm packages. Morgan is a middleware that logs HTTP requests. Chorus library will enable cross-origin request sharing for our API. We will also install types for Express, Morgan, and Chorus as dev dependencies. Let's create a file called server.ts in src folder of the project. In this file, we will import Express, request, and response from Express library, Morgan from Morgan, and Chorus from Chorus. Next, we're going to define and export create server function. In this function, we will create an Express app. We will disable X powered by response headers and add Morgan middleware. The Express URL encoded middleware allows Express to parse URL encoded form data. JSON middleware enables Express to parse JSON request body. Finally, we will add Chorus middleware. Let's create a simple getTestHealth test route. We can do it by calling get method on the Express app. Parameters to this method are the route itself and a callback function that handles the request. This callback function accepts request and response parameters. We're going to use response parameter to send OK-true response in JSON format. Finally, we will return Express app from the create server function. In index.ts file, let's import create server function. We will instantiate a server by calling that function. Then we will call listen method on the server, passing to it the port and a callback function that logs out API is running message if the server starts up successfully. It's time to test our work. We will be using REST client extension of Visual Studio Code. Please be sure to have it installed if you are working in Visual Studio Code editor. If you are using a different code editor, you can use any other available REST API client like Postman. Let's create API test.html file in the root of the project. In this file, we will create a GET request to the health endpoint on the localhost 3000. Be sure to put 3 hashtags on the line above. This will allow send request option to show right above the request. Now we can start the development server with npm run dev command. The dev script is using .env package to load environment variables from the env file in development. We will create that file and the database connection variables in a little bit. TSC watch watches the files, rebuilds the project, and restarts the server when the changes are made. Let's make a request to the health endpoint. We receive the response OK true in JSON format. The Express server is working. That's great. Now we can install Sequelize. But before we do that, if you're enjoying this video, please click the like button and subscribe to our channel for more videos like this. When developing locally, I don't use Sequelize database, as some of the tutorials suggest. I use the same database locally that is used in production to avoid any issues. Most of my time I use MySQL or Postgres relational databases for my project. For this project, we will set up MySQL database for local development. The easiest way to do it is to use Docker. Please install Docker Desktop on your local machine if you don't have it installed. In the root of the project, let's create docker compose.yaml file. In this file, we will set up a database service. We will use MySQL 8.0 image, set a super strong secret password, and create a Sequelize API database. MySQL server listens on the port 3306. We will bind this port to 33061 port on the local machine. I have another MySQL database listening on port 3306 on my local machine, and that's why I use port 33061. If you don't have anything running on your local machine on port 3306, you can put 3306 instead of 33061. Finally, we define db data volume to persist the data. To start up the database, run docker compose up-d. -d stands for detached mode. On the first run, it may take a while for the database service to start up, since Docker needs to pull the MySQL 8.0 Docker image from the internet. After all said and done, you can go to Docker Desktop to make sure the database container is running. If you want to stop the container, you can simply run docker compose down command. The docker compose will remove the database container. Since we defined the volume, the data saved in the database will be preserved even though the container will be removed. We will need the database running for the Sequelize, so let's spin up the database container back with the command docker compose up-d. Sequelize in its current version 6 still has some parts of TypeScript as work in progress, so we will be using Sequelize TypeScript library as suggested in the documentation. Let's install the following dependencies with npm: MySQL2, Sequelize reflect metadata, and Sequelize TypeScript. We will also need to install dev dependency called addTypesValidator. To use Sequelize TypeScript, we will have the enabled experimental decorator and emit decorator metadata in compiler options of tsconfig file. When I work with Sequelize, I like to put Sequelize connection and models inside a repository. Let's create a base repository.ts file in src data repository folder. In this file, we're going to import Sequelize from Sequelize TypeScript library and config from the config file. We don't have the config file yet. We will define it in a little bit. Let's export default base repository class. In this class, we will define Sequelize client public class field of the type Sequelize. In the constructor, we will assign this field a new Sequelize instance with the database connection properties of host, port, database name, username, and password. We will also specify dialect as MySQL, so Sequelize knows we are using MySQL database. Now let's create index.ts file inside data repository folder. In this file, we will import base repository, create a repository instance, and export it. Next, let's create .env file and add environment variables. We will define the port our application is running on as 3000, as well as database connection variables. Finally, let's define database connection configuration. In the src folder, create config.ts file. In this file, we will define and export database configuration options that we will get from the environment variables. The config file is not only useful for keeping all the configuration variables in one place, but also for type casting them and assigning default values. Now we can test the database connection. In index.ts file of the src folder, we will import repository. Inside the server listen callback function, we will call authenticated method on the repository's Sequelize client. If everything goes well, we will log out successfully connected to the database message. If things go sideways, we will catch an error and log it out. We are good to go. Let's start the dev server with a command npm run dev. Also, please be sure your Docker Compose is running as well. After tscwatch compiles the files, we can see that the database connection was successful and that the API is running on port 3000. This is great. The advantage of Sequelize is that it maps database tables into JavaScript objects or models. All the Sequelize setup that we did is kind of useless without the database table and Sequelize model. So please check out the next part to learn how to set up API routes in Express and define Sequelize models. I am a Node.js project that has Express and Sequelize installed and is connected to a database. Let's open API test.htp file. In this file, I added several routes. These routes basically represent a REST API. REST stands for Representational State Transfer. It relies on HTTP methods to manipulate resources. A resource is basically something your application provides access to, like users, posts, comments, and so on. In our case, we have a user resource. This resource is specified in the path part of the URL in plural form. HTTP methods in REST API allow us to perform different actions on those resources. For example, to list users or get a single user, we use HTTP GET method. If we want to create a user, we use POST method. To update a user, we use PUT method. There is also a patch method that you can use to update a resource. The difference between put and patch is that when using put method, the whole resource is replaced. But when using patch method, only some of the attributes of the resource are changed. In practice, it can get pretty tricky to determine if the whole resource is changed or only parts of it. When designing a REST API, I almost always use put HTTP method to update resources. Finally, delete HTTP method is used to delete a resource. How are resources represented in the application? Well, you have to store resource data somewhere. Usually this somewhere is a database table. Sometimes a resource can be stored across multiple tables. For example, order information is stored in both orders and order lines table. When programming, however, we don't use tables, but rather objects and models. Sequelize lets us define models in JavaScript and use intuitive methods to query and manipulate resource data. Let's create a user model in src data models folder. We're going to import creation optional infer attributes and infer creation attributes from Sequelize. Next, we will import a few things from Sequelize TypeScript. Most of them are decorators that we will use to annotate user model and model attributes. When defining a model with a Sequelize TypeScript, we use @TableDecorator. I like to explicitly specify table name and model name. My convention is to name tables and columns in lowercase plural form using snake case for multi-word names. I name models in singular form with the first letter capitalized. Next, we will export default class user. This class will extend Sequelize model to which we will pass infer attributes and infer creation attributes for the user class. Attribute ID has a type of number. It will correspond to a primary key column of data type big integer. Since it will be auto-incremented by the database, we won't need to pass it when creating a user. Therefore, we will make the ID as creation optional. Next, we will declare a name attribute of type string annotated by column decorator. Email attribute, besides being a string, will also be unique. Therefore, in addition to column decorator, we will use unique decorator as well. Finally, we will add created@ and updated@ attributes. They are utility attributes or columns of date type, and usually are used to track when resources are created or modified. We will annotate them with the created@ and updated@ decorators respectively. That way, created@ and updated@ columns will be filled out automatically. And since we won't need to pass them when creating a user, we will need to make them creation optional. Next, let's make Sequelize aware of the user model. In base repository constructor, add an attribute called models to Sequelize configuration. We can either pass it an array of models, or better yet, we can point it to the folder where the models are located. This way, we don't have to add each new model every time we create it. Now we need to somehow create a table in a database based on Sequelize user model. Normally, you would use Sequelize Migrations for that. However, our project is really small and we can get away with using sync method on Sequelize client. Let's go to index.cs file in the src folder, and instead of Sequelize authenticate method, we will use Sequelize sync method. We will also update console log statement for success and failure to successfully migrated tables and fail to migrate tables respectively. Alright, let's try it out. First, be sure you have your database running. If you are following along, you can spin it up with a command docker compose up-d. Next, we will use the command npm run dev, and in a second or two, we can see a message that the tables were migrated successfully. This is great. Let's continue. But before we do that, if you are learning something new, please hit the like button and subscribe to our channel for more videos like this. The next step will be to enable API consumers to create and modify a user resource that we just created. We will create an application interface for the API consumers to interact with the user resource using HTTP methods. The interface we create will end up calling methods on the Sequelize user model to store and update data in the database. Sequelize models are very powerful, and we will be using them throughout the application as opposed to translating them into application-specific models like we can do with Prisma ORM. Although we don't need model translation, I still like to wrap Sequelize method calls inside a repository for clean and dry code. When creating repositories, I sometimes use TypeScript mix-ins pattern. The idea of this pattern is to split up a large class in manageable pieces while creating inheritance mechanism for code reuse. In general, APIs manage a lot of resources, so repository class can get pretty big. Splitting it up from the beginning makes good sense. In the base repository, let's export constructor type. We will need it to be able to use mix-ins pattern. Since TypeScript rules we defined are pretty strict, TypeScript will complain about explicit any. We can turn off this rule in eslint.config.mjs file by adding add TypeScript eslint no explicit any off to the rules object. Let's create add user repository.cs file in src data repository folder. In this file, we will import user model, base repository, and constructor type. We will export a generic function called add user repository and pass it base of type tbase. This is a boilerplate code needed for creating mix-ins that I took from TypeScript documentation. Add user repository function returns a class that extends base, which in our case will be the base repository. We're going to create getUser method. This method will return user find all call that queries all the users. In most cases, not limiting how many records a query can return is never a good idea. Therefore, we will pass an option to find all method to limit how many users we return. Find all method can take other options, such as where to define a query, as well as offset and order by. You can check Sequelize documentation for more information. The default limit that we use can also apply to other models that we create in the future, like posts or comments. So it is a good idea to define the default limit on the base repository parent class. This way, child repositories can have access to it. We will define default limit as 100. The next method on the class is getUser. We will call user by pk method on user model. Finally, let's create user method. It will accept a name and an email user attributes and call create method on the user model. Now we need to add user repository to base repository. Let's do it in index.cs file of the repository folder. We will import add user repository function. Then we will define a combined repository and assign to it the rest of calling add user repository function with the base repository argument. We will instantiate and export default combined repository. I hope now you have a better understanding how mixin pattern works. Much like Russian dolls, we will stack add repository functions on top of each other. The repository is ready to go. Let's enable an API access to it. We will do it by defining routes. In src routes folder, let's create user.cs file. In this file, we will import express, request, and response from express and repository from repository. We will export a function create user routes to which we will pass an express app as a parameter. In create user routes function, we will call a get method on express app to define a mechanism to accept HTTP GET request for user routes. The route handler will call getUser's method on the repository and respond back to the user with a JSON object containing the users. Next, we will call a get method on the express app to fetch a single user. We will add a ID to the end of the user's path. This is a route parameter. We can access it on the params attributes of the request. Since a path is a string, the ID parameter is also a string. In order to pass it to the getUser method of the repository, we will need to parse it as an integer. We will return a user as a JSON object by calling a JSON method on the response. Finally, let's call a post method on the Express app. We will parse the name and the email values from the request body. The reason we can do it is because when creating an Express server, we attached Express.json middleware to it. This middleware takes the request stream, translates it into an object, and assigns it to a body attribute of the request. The parsed user payload will be passed as an argument to create user method of the repository, and then the created user will be sent back as a JSON response. Creating a user may not always go well. For example, a user's email may already exist, and a query to create a user with the same email will be rejected by the database. To handle errors, we wrap user creation in try-catch. In the catch block, we log out an error and return an error response with HTTP status 400. So the recipient of the response knows creating a user didn't go well. By the way, by default, Express response will send HTTP 200 OK status. That's why we didn't explicitly assign response status earlier. But if we need a different status like 400, we need to assign it explicitly. Now let's add the routes we created to the Express server. First, we will create an index.cs file in the routes folder. In this file, we will import Express and create user routes function. We will export creates routes function, inside of which we will call create user routes function. Finally, in the server.cs file, we will import create routes function and call it before returning the app from create server function. We're all set. Let's test out our work. Be sure the Express server is running. Let's go to API test.http file and send requests to get users. Obviously, there are no users in the database, so we get back an empty array. Let's create a user by sending a post request with a payload containing a name and an email. Another important thing to remember is that the Express.json middleware will parse the request body only if the content type header is application.json. Please be sure not to forget content type header when making post and put requests. We can see that the user was created successfully. Now we can fetch that user by its ID. As you may have noticed, the user response contains all the fields from the users table. Sometimes it is desirable not to expose all the fields to an API consumer. For example, you may not want to return user's password field in the response. In our case, let's say we don't want to return created@ and updated@ fields from the users table. We can easily turn off those fields by overriding toJSON method on the user model. In user.cs file, let's add toJSON method to the user model. This method will return an object in which we will splat all the properties of the model with this .get method. Then we will add created@ and updated@ properties to the object and assign undefined values to them. This will essentially hide those properties in the response. Let's go ahead and test it. In API test.http file, let's send requests to get users. Now we have one user since we just created it, and this user doesn't have created@ and updated@ properties anymore. Awesome. All we have to do now is to knock out put and delete requests. Back in adduserrepository.cs file, let's add an async method updateUser. It will take an ID and an object with the user attributes as parameters. Now, name and email can be optional, because we may update only either one of those attributes or both. There is an update method on the model to update a user where a user has certain ID. However, when updating models, I like to fetch a record first, assign properties that need to be updated, and then call save method on the model. This way, I'm able to first check if a record actually exists. And if it doesn't, send an appropriate response back. And if the record is found, I can return the updated record back. Let's do just that. We will use getUser method to fetch the user first. If we can't find the user, we will throw an error with the message user not found. Next, we will use fromEntries method of the object to filter out undefined user attributes. Finally, we will set the attributes that need to be updated on the user instance, call save method, and return the updated user. The delete user method will be a bit less involved. We will simply call a destroy method on the user model and pass it where object to filter user by ID. Essentially, this will run a query to delete a record with a specified ID. Destroy method returns 0 if the record is not found or 1 if the record is successfully deleted. Back in user.ts file in the routes folder, let's call put on the Express app to update a user by ID. Much like in the post method request handler function, we will parse user ID and user payload from request parameters and request body respectively. We will call update user method that we just created on the repository. If everything goes well, we will return the updated user in JSON format. If things go bad, for example, we can find a user record to update, we will catch, log, and return an error response. Finally, let's call delete method on the Express app to delete a user by ID. We will parse the user ID from the route params and call delete user method on the repository. We will send the result of these operations as a JSON response to notify the API user if the user record was deleted. As we already know, this result will be either 0 or 1. We're all set. Let's test the code. In the API test.htp file, send a put request to update user's name to John for the user record with the ID of 1. The API returns the updated user record. Next, let's delete the user records with the ID of 1. We got user deleted response also as 1. The user record was deleted successfully. We can confirm that by sending a request to get all users. Now users array is empty. The user API that we just built is working. We're all set. As you may have noticed, we took a pretty relaxed approach to creating and updating users, assuming we will get the correct data. This may not always be the case. To learn how to use Sequelize's built-in validation and how to handle errors in Express API more elegantly, please watch the next part of this video. I am in Sequelize Express project. Let's open API test.htp file. Earlier, we created a REST API to create, read, update, and delete a user. In other words, we implemented full CRUD on a user model. When creating a user, we trusted the API consumer to send us correct data. In our case, name and email. However, in real life, this won't be the case. We always need to be sure we validate the input. Input validation starts when designing a model. Let's go to user.ts file that contains the user model. If we think about the name field, we want it to exist on all the users, so it should be required. It also has to have certain number of characters. We want the name to have at least one character, but it shouldn't be super long. One reason to avoid making the name too long, aside from it being hard to say, is that the database field for the name has a character limit. In our case, MySQL database field that was created by Sequelize for the name is variable character or varchar and has limit of 255 characters. One of the great things about Sequelize is that it allows you to add validations to its models. According to Sequelize TypeScript documentation, validation options can be set through the add column annotation. But if you prefer, you can use separate decorators for validation instead. For the full list of validations, please check out Sequelize documentation. Let's add validation to the name column. We will add allow null decorator false. This will prevent inserting user records without the name. In the add column annotation, let's put an object with a validate property. Inside this property, we will specify that the length of the name should be from 1 character to 100. Now let's talk about email field. We already agreed that this field should be unique in case we want to authenticate users in the future. It is also a good idea to not allow email to be null. Finally, email value should have email format. To enforce that, let's add allow null false and isEmail decorator to the email property. Finally, let's not forget to import both allow null and isEmail decorators from Sequelize TypeScript. Adding validations to the models is only half of the job. Another half is to handle errors that validations trigger. Let's go to user routes in user.ts file. We can see that the code for post and put requests does have error handling via try-catch blocks. We could use the catch blocks to handle validation errors as well. However, it may not be very scalable if an API has a lot of models and a lot of validations. A better way is to centrally handle validation errors, or any errors for that matter. Express Framework has a built-in error handler. If we don't do any try-catch and if an error is thrown, the app won't crash. Let's remove try-catch blocks from user routes file. Now the responses from the Express server will contain error stack and they won't be in JSON format. We can create our own error handling middleware in addition to the Express default error handler. But before we do that, if you are learning something new, please hit the like button and subscribe to our channel for more videos like this. In the src middleware folder, let's create errorhandler.ts file. In this file, we will import request, response, and next function from Express. We will also import getErrorMessage function from utils file. This function doesn't exist yet. We will create it in a second. GetErrorMessage function will allow us to safely get a message from an error. In JavaScript, anything can be thrown as an error, therefore an error in TypeScript is typed as unknown. Before we can get a message from an error, we will need to have a logic to check the actual type of the error. GetErrorMessage function will do just that. So let's quickly create it in the utils.ts file in the src folder. We will export function getErrorMessage. Inside this function, we will check if an error is an instance of error. If so, we can safely access the message property and return its value. If an error is some other object and has a message property, we can do the same thing. If an error is a string, we can just return it. And finally, if nothing matches, we can return a message an error occurred. Now let's go back to the error handler middleware file and do the remaining import of validation error type from Sequelize. Next, we will export default error handler function. Express is smart enough to pass to it an error which is type of unknown, request, response, and next function. First, we need to check if response headers are sent. For example, if we are doing an asynchronous action that takes a bit of time, the response may be already sent back. We can send another response on top of already sent one. Express won't let us do that and will complain. In the case when the headers are already sent, I prefer to pass an error to the Express's default error handler using next function, because the default error handler does a good job at logging the error stack. Next, we will check if an error is an instance of the validation error. If it is, we will send a response with a 422 status. This HTTP status code means unprocessable entity and is often used to return validation errors. We will send back to the API consumer an object containing a general error message and error details. It is a good idea to always send an error back to the user in the standard format, no matter what type of error it is. Finally, we will add a default error response in case the error of some other type. The response status code is 500. The difference between 400's and 500's error status code is that 400's status code means that something is wrong with a client request. 422 response status code is a good example of it. 500's codes mean that the error happened on the server. In our case, this is a default error response, so we don't exactly know what may have caused it. My approach is to use 500 response status. Once again, we will return an error object with an error message that we can safely access now with a getErrorMessage function. At the end of the error handler, I also like to call next function on the error to pass it to the Express error handler. As I mentioned earlier, the default error handler does a pretty good job in logging the errors. Since at this point some errors can be unexpected, I would like to have more information about them. The last step is to add the error handler middleware to the Express server. Let's go to the server.ts file in the src folder. The error handler should be the last thing you add to the Express server. Right before returning the Express app, we will call use method on the app and pass it the error handler. We are all set. Let's test our code. After starting the dev server, go to the api-test.html file and try making create user request without name field or with a name as an empty string. We will get validation errors. Now let's remove @ symbol from the email address. We get validation error once again, so the code is working. Besides the validation error, Sequelize has other types of errors that can be used to give the consumer of the API a better error experience. One that I like to use is the connection error. This error is thrown when the database is unavailable. I like to use it to provide a more concise response and hide some application information that may be exposed when this error happens. Let's add it to the error handler. In the if statement, we will check if the error is an instance of connection error. If it is, we will respond back with the status 503 and with the error object containing the message and error details. Let's quickly test it. I'm going to stop the database with the command docker compose down and make a request to get user by ID. We get 503 response that the application couldn't connect to the database. Another Sequelize error that I like to use is the database error. This error is triggered when the database engine returns an error that is not related to model validation, but rather to SQL level issues such as syntax errors, invalid columns, and constraint violations. For example, an API consumer can request to filter results by a column that doesn't exist. In the error handler file, let's add another if statement that checks if the error is an instance of database error. If it is, we will respond with the status 500 and error message and error details. In the add user repository file, let's update getUsers method to return a non-existing attributes by adding an array with a non-existent column to the attributes property of the user's model findAll method. Let's bring our database back up with the docker compose up-d command. Finally, let's make a request to get user's endpoint. As you can see, we got a database error with a message about the unknown column in the field list. The code is working. Let's go back to the add user repository file and remove the code we used to trigger the database error. Now your API is smarter and more resilient with proper validation and centralized error handling. But there's still one more important piece missing. How do you keep your database structure in sync across environments and teams? That's where Sequelize migrations come in. In the next part of this video, I'll show you how to set up and run migrations step by step. I am in Sequelize Express project. Earlier, we created a user model and then a table for it using Sequelize sync. Although sync method can be useful in development, it is not very extensible because if you need to change the table, you will have to drop already existing one, update the model, and resync it. A better approach is to use migrations. With migrations, you can transfer your existing database into another state and vice versa. Those state transitions are saved in migration files, which describe how to get to the new state and how to revert the changes in order to get back to the old state. And just like other files, migrations are a part of your code and are version controlled. Sequelize has a very good support for migrations. Unfortunately, migrations in Sequelize are not in TypeScript yet, so in order to use TypeScript with Sequelize migrations, we will be using umzug library instead of Sequelize CLI. Umzug is a framework-agnostic migration tool for Node. It provides a clean API for running and rolling back tasks. Let's go ahead and install umzug and tsnode libraries in our project. Unlike other TypeScript files that are being compiled in the dist directory, we will be compiling and running migrations on the fly with a tsnode. The entry file to run migrations will be migrate.js. We're going to create it in the root of the folder and put the following code. This code is going to require tsnode register and the umzug configuration file that we are going to create in the src folder next. TypeScript ESLint will complain about require imports. We can turn off no require imports rule in ESLint config.mjs file. In the src folder, we will create umzug.ts file. We will import umzug and Sequelize storage from umzug. Sequelize and options from Sequelize and config from config.ts file. First, we need to create a new Sequelize instance by instantiating Sequelize with the database connection parameters that are pulled from the environment variables into config.ts file. Next, we will instantiate and export migrator, passing options to umzug. Migration options point to the folder where we will be storing migrations. We're going to put them in the data folder. When specifying the path to migrations, we do it relative to the folder we are currently in. _ dir name tells umzug that we are currently in the src folder. Since Umzug is framework agnostic, we will specify Sequelize as the context. We define storage as Sequelize storage. Basically, we're going to store the migration history in the database in the migrations table. Finally, we will send the migration logs to the console. One last thing to do is to export migration type that will be used in the migrations. In package.json file, let's define several scripts that we will be using with the migrations. The first script will be migrate. We will use .env to load environment variables from the .env file and call the command node migrate up. The migrate rollback script will be very similar. We will call node migrate down. Finally, a script to create a migration will call node migrate create. We're all set. Now we are ready to write an actual migration. Writing migrations using Umzug is exactly the same as writing migrations using Sequelize. Therefore, you will be referring to the Sequelize documentation on migrations. If you will need more information on how to configure and run Umzug, you can check its documentation on npm. Let's run the migration create command and name the migration users_table.ts. If this is the first migration and migrations folder doesn't exist yet, you may have to explicitly pass the folder where you want your migrations to live. In our case, this is src data migrations. The same folder will be specified in umzug.ts file. We're going to remove everything that's in the migrations file and put the following code. We will import data types and Sequelize from Sequelize and migration type from umzug.ts file. The way migrations work is you have two functions, up and down. You write the up function to create tables, columns, or indexes, and you write the down function to undo whatever up function does. This way you can revert the migration. In production, you will probably never revert the migrations. However, in development, reverting is very useful because creating database schema is an iterative process. Okay, let's create the up function. It will be an async function that will return migration type and it will take Sequelize as context. We will call getQueryInterface first and then create table method. Our table will be called users. We will define ID of type big integer, primary key, and auto increment. Name column will be type of string and we won't allow null. The same thing goes for email column. Finally, we will add created at and updated at timestamp columns. The down function will be pretty easy. All it will do is drop the table users that we created in the up function. As I mentioned before, we will be running migrations using tsnode, so we won't need them compiled. If you like, you can go to the tsconfig.json file and exclude umzug.ts file and migrations folder from the compilation in order not to bloat your disk directory with the unnecessary files. The last thing to do before we run the migrations is to remove Sequelize sync code in index.ts file. This code created users table. Since we're going to create users table using the migration, we need to drop the existing users table created by Sequelize sync. I will use table plus client to do that. We're all set. Let's run migrate command. This command will create the users table. We can inspect it in table plus client. When we inspect the database structure, everything looks good except for that we forgot to make email column unique. As I said earlier, creating the database table is an iterative process. This is where the down migration function comes handy. Let's run the command migrate rollback. This will drop the users table. In the users table migration file, let's add unique true attributes to the email and run the migration again. Now, when inspecting the users table, we can see that the unique email index has been added to the email column. This is great. At this point, you probably have a question. How do models relate to migrations? Sequelize models define the structure of your data in code, including fields, types, and validations, and are used at runtime to interact with the database. Migrations, on the other hand, are version-controlled scripts that apply changes to actual database schema, such as creating or modifying tables. While models describe how your data should look, migrations ensure those definitions are reflected in the database over time. Sequelize does not automatically sync models to migrations, so you must keep them consistent manually. Now that your database is version controlled and ready to go, it's time to level up your data relationships. In the next part of this video, we will dive into one-to-many associations in Sequelize, like how a user can have many posts. It's a key concept for building real-world apps, so be sure to stick around. Data in your application doesn't live in isolation. For example, an order can have line items or a user can have posts. These data interactions are called relations in terms of the database, and specifically in Sequelize, they are called associations. Sequelize supports one-to-one, one-to-many, and many-to-many associations. The one-to-many is the most used association. Let's take a look at how we can implement it. Let's enable users to have posts. As usual, we start with a post route. In API test.htp file, let's define a route to create a post. Since this is a post route, no pun intended, we need to specify content type header to be application JSON. The payload will contain post title, body, and user ID. Normally, this will be an authenticated user that uses the application. However, to keep things simple, we will just send a user ID in the payload. Let's go ahead and implement this route. The first thing we're going to do is create a table for posts using Sequelize Migrations. We're going to run a migration create command and name migration file post table.ts. In the migration file, we're going to import data types and Sequelize from Sequelize and type migration from umzug. The up function will create a posts table with the ID of type big integer auto-increment primary key. The next column will be user ID. Posts in the database will relate to the users through this column. The type of user ID column needs to match the type of ID column on the users table. We set it as a big integer. We will specify that user ID column references users on key ID. The next thing we need to do is to decide what to do if the ID of a user gets changed or a user gets deleted. The possible choices are restrict, cascade, no action, set default, and set null. The choice depends on what makes sense for your application. For example, in e-commerce application, if an order is deleted, it doesn't make sense to keep that order's line items. Therefore, they can be deleted as well. In this case, you can use cascade action. In our case, if a user gets deleted, we may still want to keep their posts, so we will use set null for onDelete. If a user's ID gets updated, in our case it is unlikely since the ID is the primary key, we should update user ID on the posts table. Therefore, we use cascade action for onUpdate. We're done with the ID column. Now we can define title to be type of string and body of type text, and the usual timestamps created at and updated at. The down function of the migration will simply drop the posts table. Let's go ahead and run the migration with the command npm run migrate. The migration ran successfully. If we look at the posts table in the database, we can see all the columns we defined. We also can see two indexes. One is the primary key on the ID column, and the other one is user ID on user ID column. User ID is sometimes called a foreign key because it points to an ID that lives in a different table. When we define a foreign key constraint in MySQL database, it indexes it by default to make queries faster. The same is not true when working with a Postgres database. You have to decide for yourself if you want to index foreign keys. Okay, moving on. Next thing we need to do is create a post model. Sequelize does not automatically sync models to migrations, so we must keep both models and migrations consistent manually. Let's create a post model. We are going to create post.ts file in the src data models folder. We will import creation optional as well as infer attributes and infer creation attributes from Sequelize and decorators from Sequelize TypeScript. Since we're going to associate posts to users, we will also import a user model. We will export default class post that extends Sequelize model. We will define ID as primary key and creation optional since it will be assigned by the database. Besides the column decorator, user ID will have a foreign key decorator that references the user model. We will define title and body columns that will have basic validations. Created at and updated at columns will be also creation optional because Sequelize will automatically populate them. Next, we will add a property called author. This will be a user the post belongs to. Author column does not exist in the database. It exists only in Sequelize. You can name this association property whatever you want. It will show up on the post model if you query posts and tell Sequelize that you need to fetch the user for that post as well. Finally, we will hide user ID, created at and updated at properties from the response using toJSON method. Next, let's go ahead and define the post association on the user model. In the user model file, we will import hasManyDecorator from Sequelize TypeScript and the post model. Towards the bottom of the user model definition, let's declare an optional posts property of type an array of posts. The posts column doesn't exist on the users table and only defined by Sequelize. We will use hasManyDecorator to associate this property with a post model. Great, now let's create a post repository to be able to create posts and later to query them. In the src data repository folder, create a file at postrepository.ts. We will import post, user, base repository, and a constructor type. The constructor function at postRepository will return a class that extends the base. In this class, define createUserPost method. This method will accept a user and post attribute. Rather than calling create method on the post model, we will take an advantage of the association we created. We will use $create method on the user to create a post. This is how you can create an entity using an association in Sequelize TypeScript. This approach is usually useful when an instance has already been fetched, for example, during an authentication process. The last thing to do is to add posts repository to the main repository. In the index.ts file in the repository folder, let's import add post repository and add it to the combined repository. Now let's go ahead and create post routes. In the src routes folder, let's create post.ts file. We will import express, request, and response from express and repository from repository. An exported create post routes function will accept an express app as a parameter. On the express app, we will call post method to handle the create post request. We will extract user ID and post payload from the request body. We're going to get user by its ID. If the user is not found, we will return 404 user not found response back. If the user exists, we can pass it together with a post payload to create user post method that we just defined in the repository. Finally, let's update index.ts file in the routes folder to include the post routes. We're all set. Start the dev server and make a create post request from the API test.http file. The post was created successfully and assigned to an existing user with the ID of 1. Similar to how we used a user and post association to create a post, we can use a user and post association to get posts. Let's create a get request to list post by user. Again, this is a bit of a contrived example. Normally you will get a user from the authentication, but in our case, for simplicity, we put user ID as a route parameter. In add post repository file, let's add getUserPost method that will take a user as an argument. We will call $get method on the user instance and specify post association. As a second argument, you can put options object the same way you do with a getAll method. In our case, I will use the default limit that I defined earlier on the base repository class. In user.ts file in the routes folder, let's add app.getRouteHandler for user post route. We will get user ID from the route parameter and attempt to fetch a user by this ID. If we don't get a user, we will return a 404 user not found response. Otherwise, we'll call getUserPost method on the repository, passing to it the user and respond with a returned post in JSON format. In API test.http file, let's make a call to get posts for a user with the ID of 1. We get back an array with 1 post that we just created. Great. Fetching a user first and then getting posts associated with a user is called lazy loading. Although convenient, lazy loading sometimes can lead to n+1 problem. The n+1 query problem occurs in data access when an application retrieves a list of data and then for each item in the list makes an additional query to fetch related data. In our case, if we get a list of users and then for each user we get posts. To avoid n+1 problem in certain cases, you can use eager loading instead of lazy loading. Let's take a look how to eager load a user when fetching posts. First, let's define a getPost route in API test.http file. Next, in the addPost repository file, add getPosts method. We will use findAll method on the post model and pass it an options object. As usual, we will limit the number of posts we retrieve by setting the default limit. Besides the limit, we will define an include object. This include object will enable us to lazy load a post user, in our case an author. We will assign user model to the model property. Optionally, we can use attribute property to specify which user fields we want to include. We will include ID and name. In our case, a post can have only one user. However, if you are trying to eager load posts on a user in the include object, you can also use Sequelize query attributes such as where, limit, order by, and others. Next, in a post.ts file, let's define getPostRoute handler by calling a get method on the app. We will use getPost method on the repository to get posts and return them back in JSON format. Finally, let's go to API test.http file and make a call to list posts. In the response, you can see that a post now has an author attribute with the ID and the name of the user that the post belongs to. Sequelize TypeScript figured out that it needs to use the author property that was defined on the post model and attach the user to it. Also, if we take a look at the console, we can see eager loading produced only one query instead of two, using left outer join to retrieve the related user. Now that you've seen how one-to-many associations work in Sequelize, it's time to level up your skills even further. In the next part of this video, we'll tackle many-to-many relationships perfect for classes like users with multiple roles or posts with multiple tags. You'll learn how to create junction tables, define models, and query complex relationships with ease. Many-to-many associations connect one source with multiple targets. This cannot be represented by adding one foreign key to one of the tables, like one-to-many relationship did. Instead, the concept of a junction model is used. This will be an extra model and extra table in the database, which will have two foreign key columns and will keep track of the associations. The junction table is also sometimes called join table or through table. We want to create post tags many-to-many association. Posts can have many tags and tags can have many posts. Unlike with one-to-many association, it is hard to determine which table, posts, or tags will have a foreign key. In this situation, neither of them will. We need to use a post tag junction table that has post ID and tag ID foreign keys. Since the combination of the post ID and tag ID is unique because we can tag the same post many times with the same tag, we will also set post ID and tag ID as combined primary key. This will ensure the uniqueness of the post ID and tag ID combination because primary key is essentially a unique key that can't be null. With regard to the name of the junction model, I like to follow the convention where I use singular form and the parts of the name are in alphabetical order. So the name of the table is post tag since post comes first alphabetically. Let's go ahead and implement post tag many-to-many association. In the API test.http file, let's add tags property to create posts payload. It will be an array of two tags, hello and world. We will create a post and tag it at the same time. In order to implement this functionality, we will need to create posts table and post tag junction table. First, we create tags.table.ts migration file with npm run migration create command. Next, we will create post tag table.ts migration file. In the tags table migration file, we will import data types and Sequelize from Sequelize and migration from Umzug. The up function will create the table with the following fields: ID, big integer, primary key, and auto increment, unique name because we don't want duplicate tag names, and created at and updated at timestamps. The down function will simply drop this table. In the post tag table migration file, we will import data types from Sequelize and migration type from Umzug. The up function will define the post tag table with only two columns. Those are the only columns that we need to connect posts and tags. The post ID column is of data type big integer. We set it as a primary key. Post ID references ID column on the post table, and the cascade action is applied on both delete and update. The second column is tag ID. It is similar to the post ID column. It references ID column on the tags table. Note that by adding primary key true to both post ID and tag ID, we create a combined primary key on those columns. The down function will drop the post tag table. The next step is to create tag and post tag models. Let's first create tag.ts file in the src data models folder. In this file, we will import the necessary attributes from Sequelize and the decorators from Sequelize TypeScript. Also, we will import post and post tag models. Post tag model doesn't exist yet. We will create it next. We're going to export default class tag that extends the Sequelize model. ID column will be a primary key of the data type big integer. The name column will have allow null false. We will add a length validation to it. Besides the usual created at and updated at fields, we will also add a posts field. This field will have belong to many decorator. It tells Sequelize TypeScript that the tag model belongs to the post model through the post tag junction table. The posts column doesn't exist in the tags database table and will be populated by Sequelize when fetching the relation. Finally, the JSON function will hide created at and updated at fields when the model is serialized to JSON. Let's create posttag.ts file in the src data models folder. In the posttag model file, we will import the usual attributes and the decorators and also post and tag models. In the table decorator, besides the table name and model name, we will specify timestamps false since posttag table doesn't have created at and updated at columns. We export default post tag class that extends the Sequelize model. We define the post ID attribute as a foreign key of the post model and the tag ID attribute as foreign key of the tag model. The final step in setting up the association is to add the belongs to many relation to the post model. In the post.ts file in the models folder, let's import tag and a post tag. Towards the end of the class, we're going to define the attribute tags with belongs to many decorator that specifies that the post model belongs to the tag model through the junction model post tag. We're all set. Let's add the code to the add post repository to be able to tag a newly created post. In the create user post function, let's add an optional tag name parameter of the type an array of strings. Since we define the tag relationship on the post, we can use $create method on the post instance to create tags. However, the tags are unique, so the next time we attempt to tag a new post with the same tag, the create method won't work because the database will throw a unique constraint error. What we will do instead is check if we have a tag names parameter first since it is optional. If we do, we will use promise all to map the tag names to the tag upsert method on the model to create or update the tags. We can use the upsert method because the tag name is unique. After upserting the tags, we now can use $set method to set tags on the post model. Finally, we return the created post. And of course, we also need to add the necessary imports. The final step for the tagging to work is that we need to update the post.ts file in the routes folder to pass the tags from the request body into create user post method as the third argument. Now all we have to do is to run the migrations with npm run migrate command, spin up the dev server, and go to api.htp file to make a create post request. A post was created successfully, however, the response didn't return the created tags on the post. In order to include the created tags on the post, we need to eager load them. In the create user post method of the add post repository, let's use reload method on the post instance that was created. This method will fetch the post from the database. Now we can use include property in the options to eager load the tags. We will select just the ID and the name of the tag. When we make create post request again, we can see that the tags are now included in the response. But besides the ID and the name of the tags, also include a post tag junction object. We can remove it by adding a through property to the include object. In the through property, we set the attributes to an empty array. This will include post tag from the results. While we're at it, let's also include tags in the getUserPosts and getPosts methods. Now, if we make a call to list posts, we can see that the tags are included in the response without post tag. This is great. Now let's take a look at how we can use the many-to-many association to retrieve posts that belong to a tag. Let's create a route list post by tag. We specify tag ID 1 as a route parameter. In the add post repository, create a method getPostByTag. We're going to pass a tag ID to it as a parameter. First, we're going to fetch a tag by the ID. If the tag is not found, we will throw an error that will be handled and returned back as an error response by the error handler. If there is a tag, we will use $get method on the tag instance to get posts passing in options the default limit that we defined on the parent repository and include property to eager load the tags. As you may have noticed, we have many-to-many association twice. First, we lazy loaded the posts on the tag instance with the $get method, and then we eager loaded the tags on the posts using the include property in the options. Let's add the route to get post by tag ID to the post.ts file in the routes folder. In the route handler function, we will get the post by calling getPostByTag method on the repository and pass it a parsed tag ID from the request parameters. Now we can go back to API-test.htp file and make a request to get posts by tag. We receive the response that contains posts that are tagged with a tag that has ID of 1. Besides the tags property, the response also includes post tag model. If you want to exclude post tag from the response, you can do it by setting join table attributes property to an empty array in the options of the $get method. If TypeScript complains, you can use as any type assertion. Now, if we make a request again, we can see that post tag object is not returned anymore in the response. And this is how you set up many-to-many associations with Sequelize. Now that your models are connected, let's take it a step further. In the next part of this video, we will dive into Sequelize accessors and hooks, powerful tools that let you add custom logic to your models and automate actions like formatting data or handling side effects. Sequelize allows you to define custom getters and setters for the attributes of your models. Let's take a look how we can add accessors or getters and setters to our models. We have a Sequelize user model that we defined in one of our previous videos. Let's say we want to display user's name in all caps. What we can do is to use a getter function that will call to uppercase method on the user's name. Class getters and setters in Sequelize work the same way as in JavaScript. Therefore, instead of declare name, let's put getName. In the getter method, we will retrieve the original value for the user's name by calling getDataValue on this and passing it to the property name for user's name, which is name, no pun intended. Then we call to uppercase method to make the name all uppercase. And that's it. There is actually something you need to be aware of when using getters and setters. The methods you may call on or pass the value to may not work if the value is null or undefined. In case of the name getter, we don't have to worry about this because the name can be null. So there is always be a value in the database for user's name. But if you don't have such constraint, always check for null or undefined values. Next, let's use a setter for user's email. Sometimes people use random capitalization when entering their email. That's why it is a good idea to store emails in the database normalized, all lowercase. Instead of declare email, we put email setter. This setter will accept the value of string type. Similar to the getDefaultValue, we will call setDefaultValue method on this and pass the attributes name, which is email, and the value we want to set. As I mentioned before, we have to be careful not to call to lowercase method on null or undefined. Since we can't be sure email will always have value, we will use ternary operator to check if email value is not null. And that's all it takes to use a setter. Now we can start the development server with npm run dev and head to API-test.htp file to check our code. First, we're going to call list users endpoint. We can see that the returned user's name is capitalized. Next, let's create a new user with the email in all caps. The API returns back a newly created user, and we can see that the user's email is all lowercase. The accessors are working. Now you may be wondering how to access the original value of an attribute that has a getter. We can do it by calling getDataValue method on the instance. In the user route file, let's update the return from getUserHandler. We will access the user properties by calling getMethod on the user instance. Then we will add original name property and assign it the original value. We're all set. Let's make a call to getUser with the ID of 1. We can see that the value for the original name property is the name of the user the way it is saved in the database. Besides already existing attributes, you can also define virtual attributes, which are attributes on the Sequelize model that don't really exist in the underlying database table, but instead are populated automatically by Sequelize. They are very useful to create custom attributes, which also could simplify your code. Let's add a virtual field called joinedOn to the user model. But before we do that, if you're enjoying this video, please hit the like button and subscribe to our channel for more content like this. In the user model, let's add an additional getter called joinedOn. We will annotate it with a column decorator with a virtual data type. The joinedOn getter will simply return a created@date without time. If we make a call to get users now, the response also contains joinedOn attribute with a date when the users were created. And this column doesn't exist in the table. How cool is that? Another cool feature of Sequelize are hooks, also known as lifecycle events. Hooks are functions which are called before and after calls in Sequelize are executed. For example, if you want to always set a value on a model before saving it, you can add a beforeUpdate hook. Sequelize provides a lot of hooks. The full list can be found in Sequelize documentation. One application for a hook could be creating a slug for a post. When a post page is displayed, instead of using post ID, it is better to use a human-readable slug so the post's URL gets indexed by search engines. Let's use beforeCreateHook to generate a post slug. In the post model, we will add a static async function generateSlug decorated by beforeCreate. This function will accept a post instance. You can optionally pass a property name of type string to it as well. GenerateSlug function will count how many posts are created in the database with the same title. If there are already existing posts, it will add a suffix that will be a number of posts incremented by 1. Then it will update the slug property of the instance with a generated kebab case slug. Next, let's import a beforeCreate decorator and an actual slug attribute in the post model. It will be of type string. Finally, we will create a migration to add the slug column to the database with npm run migration create command. We name migration add slug to posts table. The app function of this migration will add a column slug to the posts table. This will be a unique varchar column. We set this column to be unique to make sure each post has a distinct slug. Another thing that I like about Sequelize and MySQL in particular is that you can put added columns not just at the end of the table, but basically where you want. We want to put the slug column after the body column. TypeScript definitions don't recognize after officially, so TypeScript may still complain. You can bypass that with as any type on the options. The down function of the migration will simply remove the slug column from the posts table. We're all set. Let's run the migration to add a slug column to the posts table with npm run migrate. After the column is added, we can go ahead and spin up a dev server and create another post. After the post is created, you can see a slug property in the response. If we create the second post with the same title, the slug property will now have suffix -2. And this is how you can easily generate a unique post slug using Sequelize hooks. Hooks open a lot of development possibilities. This feature is one of my favorite in Sequelize. And that's how you can use Sequelize accessors and hooks to clean your data and simplify your code. But we're not done yet. If you want to learn how to safely delete records without actually losing data using Sequelize self-deletes, check out the next part of this video. Soft delete is a strategy where a database record is not permanently removed, but instead marked as deleted, usually by setting a deleted at timestamp. This allows the data to be recovered later, supports audit trails, and prevents accidental data loss. Sequelize supports the concept of soft deletes through the use of paranoid models. A paranoid model is one that, when told to delete a record, will not truly delete it. Instead, a special column called deleted at will have its value set to the timestamp of the deletion request. Let's take a look at how to implement soft deletes in Sequelize. Earlier, we created a model called user. Let's make this model paranoid. To do that, we will add paranoid true option to the table decorator. Next, we will add deleted at property with deleted at decorator from Sequelize TypeScript. Finally, we will make this column invisible to the API users by assigning undefined to deleted at property into JSON method. All we have to do now is to create a deleted at column in users table. Let's run npm run migration create command. We will name the migration add deleted at to users table.ts. The up function for this migration will add a column of type date to the users table. The down migration will remove the column. It's that simple. Let's run the migration with npm run migrate. After migration is completed, spin up the dev server. In the API test.htp file, let's create a new user with the name soft delete. The user was created successfully. We can confirm that by making an API call to list all users. There we can see a soft delete user. Let's copy this user's ID and delete the user record. The user was successfully deleted. If we attempt to get the user by ID, the response returns an empty user. If we look at the users table, we can see that deleted at column for soft delete user has a timestamp. Paranoid user model is hiding this user when queries are made. But it is possible to retrieve the soft deleted user. Let's go to add users repository, find get user method, and add an object with paranoid false as a second argument to find by pk method. Now, if we make a call to get user by ID, we can see that user. Setting paranoid to false only works for a specific query. In our case, it will only work when getting a user by ID. If we make a call to list all users, we still don't see soft delete user in the users list returned by the response. Sequelize has also an option to restore the soft deleted record. Let's do just that. In getUser method of the repository, we can call restore method on the user model and pass it the user's ID. After we make a call to get user by ID endpoint, this user will be restored and we can see it in the list user's response. And that's how you implement soft deletes in Sequelize with paranoid models. Your data is safer and your API is smarter. In the next part of this video, I'll show you how to seed your database effectively using Sequelize. It's great for building realistic development and testing environment. I am in Sequelize Express API project where we created users, posts, and tags resources. At this point, the project needs some sample data. Let's take a look at how to add sample data using Sequelize seeders. Seeders and migrations are very similar and use the same code under the hood. We used umzug to create Sequelize migrations. We're going to be using umzug to create a seeder as well. Let's go ahead and create seed.js file in the root of our project. In this file, we will require TS Node register and umzug seeder to run as CLI. TS Node and umzug libraries were installed in the project during the migration setup, so we don't need to install them again. The next thing we need to do is to update umzug.ts file in the src folder. We already have a migrator in this file. Let's add a seeder to it. We will create seeder by instantiating umzug and passing pretty much the same options we passed when instantiating the migrator. The only two things we will change are the folder where we're going to be storing seeders and also the table where we are going to be keeping track of seeders. Also, for some reason, table name property is not going to work in the seeder options. The way to create a separate table to keep track of migrations is to specify a model name property. After instantiating and exporting seeder, we will also need to export seeder type to use in the seed files. Next, let's add seed scripts to package.json file. We will use the same pattern as we used with the migration. We're going to do dbSeed, dbSeed rollback, and seeder create. And don't forget to use .env so the scripts pick up environment variables. Let's create our first seeder. We can do it with the command npm run seeder create. We are going to name the seeder users posts tags seeder.cs. We're going to get an error since the folder seeders don't exist yet. This is a one-time error. Let's rerun the command and specify the folder src data seeders. The seeder is created successfully. Great. Let's create seeder code. We will import seeder from unzug.cs file we updated earlier. Next, we will define users and posts arrays. Posts have their user ID reference the IDs of the users. Next, we will define tags and post tags array. Objects in the post tags array are referencing objects from post and tags array. This is the data for the junction table. Similar to migrations, seeders also have up and down functions. In the up function, we will define query interface by calling getQueryInterface on Sequelize. Next, we will use bulk insert method on the query interface to insert data in users, posts, and tags and post tag tables. Bulk insert method inserts the records in bulk, making it much faster than inserting records one by one. Technically, you can bring your repository and models into the seeder to populate data, but I usually don't do it to keep my seeder decoupled from the application model. The down function uses bulk delete method on the query interface to quickly delete inserted records. We also pass options to the bulk delete to be sure we're deleting the records with the IDs that we created. We do deletion in the reverse order to avoid foreign key constraints issues. Also, you may remember that we set up foreign key constraint for post IDs and tag IDs in the post tag table to be on delete cascade. Therefore, you don't really need to run bulk delete on the post tag table because the records in this table will be removed automatically when either posts or tags are deleted. Alright. Let's go ahead and run the seeder with npm run dbSeed. Before you do that, please be sure to delete any existing records in your database so the seeded records don't collide with the existing ones since the primary keys can't be the same. I will do it by jumping in Table Plus and manually deleting the records. Our seeder ran successfully. To check if the down function works, we can run the command npm migrate dbSeed rollback. Looks like unseeding worked as well. When seeding data, I use a library called Faker.js. This library not only helps you to populate fake data, but also makes your seeders more dynamic. Let's take a look at how to use it. But before we do that, if you're enjoying this video, please hit the like button and subscribe to our channel for more videos like this. We're going to install Faker.js library as a dev dependency. In the seeder, we will import Faker from Faker.js library. Faker library has great documentation. You can find it by going to faker.js.dev. When you click on Browse API, it will show you the API modules you can choose from. In our case, we need fake names and emails for users. You can find full name method under person module. If you click on it, it will show you the definition of the method and examples. This documentation makes Faker.js library real easy to use. Let's go back to the code and see how we can make our seeder more dynamic with the Faker.js library. We will define the users array a little bit differently. We will use array from method to create an array and map it. In our case, we will create 10 users. We will define user ID as an array index offsetted by 1. Since we don't have records in the database, this will work just fine. If you already have records in your development database, you don't have to delete them. You can just use a bigger offset to bypass those records, like 10 or 100. We assign a value to name by calling fullName method on Faker's person module. We will get a fake email by calling email method on Faker's internet module, and we will leave created@, and updated@ timestamps as we had them before. Next, let's update posts array to use Faker. We will also use array from to create 10 posts. Let's define title as Faker book title. You can use different Faker module if you want to, but I will use book module. The reason we are defining the title is because Faker has helpers module and will help us to create the slug from our title. In the post object, we will define the ID of the post offsetted by 1 and the title. The body of the post will be paragraph of lorem ipsum. As I said before, Faker will help us create the slug with the slugify method of helper module. We optionally can make it lowercase. To set user ID, we will use array element method of helper module as well. This method will choose one of the user's IDs at random. Created@ and updated@ will be the dates. Next, let's define tags array. We will create 5 tags, offset the index by 1, and have the tags to be a word of lorem ipsum. Finally, let's define a post tags array. We will map over the posts and use Faker array elements method to choose 3 tags from the tags we created earlier. Next, we will map over the array of 3 tags and assign them to each post. Post tags will be basically an array of arrays of tags for each post. Therefore, we will need to update bulk insert logic for post tag. We will wrap bulk insert method in the for loop that will loop over the top array of the post tags. We're all set. Let's run the seeder with npm run dbseed, and as you can see, the seeder ran successfully. We can spin up the dev server with npm run dev and go to testapi.htp file to check the data. When we make a GET request to user's endpoint, we get the seeded users, and when we call GET posts, we can see the seeded posts. And this is how you can use Faker.js library and Sequelize seeder to create development data for your application. Seeders can be useful not only in development but also in production. I usually use seeders to seed utility data for my application, such as zip codes, lookup tables, or initial roles and permission structures for ACLs. Since the seeders are kept track in a separate table, they won't run twice, and it is safe to run seed command over and over again during the application deployment process. And that's how you can supercharge your development workflow using Sequelize and Faker.js. I hope you enjoyed this video on Sequelize, but don't stop here. Now that you know how to use Sequelize effectively, it's time to put your knowledge to use. Check out my next video where I show you how to build a powerful API using Node.js and Express. You'll learn how to structure your endpoints, handle errors gracefully, and make your API production and deployment ready.